Alright, this is the 2011 Form A test. This is going to be question number 1. I assume you've already read the question and tried them on your own, or else this is a complete waste of your time. So let's quickly go through this question. On part A, let's see, I got to get to the right pen tool. On part A, it says, is the speed of the particle increasing or decreasing at 5.5? Give a reason for your answer. So they've given us a velocity equation and an acceleration, and we know that in order to be speeding up, they have to match. They'll be slowing down anytime the two are working against each other. In other words, one's a positive and one's a negative. So I simply need to find v of 5.5 and a of 5.5 and see what I get. So I've already put in my calculator. So I'm going to go to the table. I'm going to plug in 5.5 for both. And velocity is negative 1.941 and negative 1.359. So the speed is increasing because both v of 5.5 and a of 5.5 are negative. Or you could say are the same sign. Alright, there you go. Part B, find the average velocity of the particle. Alright, so here's that kind of tricky question, or at least maybe I'm making more of it than there really is. But when you see average velocity, the first thing you should think of in terms is, oh, I take my position equation and I find the slope of it. But notice we don't have a position equation. What we have is a velocity equation. So they've asked you to find the average velocity, and velocity is what we have. So this becomes now more of about adding up all the velocities. In other words, integrate. So I'm going to integrate from 0 to 6 my velocity function, and I'm going to multiply it by 1/6 to take the average, so that adds it up, and then divide by 6. And so I'll let my calculator do the math here. Math 9. Put that in y1, x comma 0 to 6. So the integral is negative 0.49. I'm going to divide it by 6, and I get negative 0.816, and that would be what unit? They don't seem to give a unit unless I'm missing it. Particles moving, velocity of the particle is given by, the acceleration is given by. Yeah, we don't have any number or any units. So it looks like my velocity is negative 0.0816 as an average. Kind of an ugly little number, but should be good. Part C, find the total distance traveled by the particle. So the total distance is simply going to be integrating from 0 to 6, but this time I need to account for the positives and negatives and make them all positive. So the easy way to do that is to integrate from 0 to 6 of the absolute value of velocity. And so I'm going to go back and just do second enter, although at this point it might be easier just to retype it. But I need to put the absolute value now, which can be found under number on math. So the absolute value of y1, put that in parentheses. Yeah, at this point it would have been faster just to retype it. Okay, so absolute value of y1, x comma 0 comma 6. Good. And I get a delay, and I get 7.2. Oh, what is wrong with me? 420.3. Again, I don't have any units, so really nothing to put there. And part D. For 0 to 6, the particle changes direction exactly once. Find the position at that time. Okay, so there's a couple things it wants me to do. The first is I need to locate this exactly one time when we change direction. So I need to find when the velocity equals 0. And so I'm going to go to my graph, and I need to find when velocity is 0. 1, 2, 3, 4, 5, 6. Okay. So, and to save time, I didn't need the acceleration graph, and it's still graphing it, so I could have turned that off. So calculate 0, left, right. Alright, so it says it equals 0 at 3.04619991. And so now I want to know, find the position. So that means I need to know, where did you start? So I started at 2. And I'm going to add to that what happens as I go from 2 to 3.04619991 of the velocity. So that's all I need to do. And so math, 9 variables, y1, comma, x, comma, 0, comma, and then I could type in 3.046, or I could just put x again, because that's the last thing I found. So that's going to give me an answer. 3.465, so I add that to 2, and I get 5.465. Okay, I think we're done. So let's see how we did. If I can find. Alright. So velocity at 5.5, the acceleration at 5.5, the two numbers, the speed is increasing because they both have the same sign. So 2 points for that, for your conclusion and your answer, and your reason I should say. Alright, 1/6 of the velocity, 1.9, oh, I made a mistake. I didn't like that number. I wonder what happened. Where is it? Here it is. So I did the right equation. So 2 points, one for the integral, one for the answer. So I got the integral. I don't know what happened. I'm going to do it again real quick. Oh, and I got C wrong as well. I wonder if I typed in my velocity function wrong. Let's check it, because now I'm unhappy. 2 sine, I couldn't have because I got these numbers right. Let's check it. 2 sine e to the 0.25 t, yeah, plus 1. Alright, let's try that again. So let's go math, 9 variables, y1, x, comma, 0, comma, 6. Yeah, I'm getting the same thing. Alright, you probably know what's happening, you viewers at home. I'm not seeing it right now. Let's see what my time is up to. 9 minutes. Alright, I got time to solve this. Alright. Find the average velocity of the particle. So I'm adding up the velocities. 0 to 6. Reading the question. Alright, I'm not seeing it. I'm in the right mode. let's go look at this again. Sine e to the t over 4 is the same thing as 0.25. It's 1/4 t, so we got 0.24 t plus 1. Very strange, I have it typed in right. Well, I'm retyping it in, sorry. X, comma 0, comma 6. Still got the same thing wrong. Okay, well, I'm going to stop this video here, and I'll start question 2 with the solution as soon as I have figured it out.